Hi guys, welcome back. So finally got some time on my hands to, I'm going to say pretty much complete the generator, at least ready to go back on the boat. I don't think the boat's quite ready for the generator, but it'd be nice to have the generator on standby and then we know we can get it on at least. So today's plans is to finish off the exhaust. We need to get these gases outside of the boat, and also we need to get full of seawater when the time comes when we actually do our plumbing for that. But so yeah, I've got myself some nice 316 elbows which we can got a load of these, so we could sort of, the plan is that's going to go up there, that's going to go around there, that's going to go down there, then we're going to introduce the raw water will end up going into the exhaust around here somewhere. Hopefully you can see. Right, we'll do a quick drawing and then we'll get stuck in. So here's our engine, here's our exhaust ports. It goes into our exhaust manifold. So we've already got water around the manifold here. So then we're going to go uphill with our 90. So with one of these 90s, so that'll be there. Then we're going to go horizontal, and then we're going to go another 90 that way, and then another 90 that way. So then the excess water from the heat exchangers will be coming in maybe around here, maybe. So we've already got cooling water around this part here, so that keeps this part at coolant temperature, which is about 80 degrees. Then we've got exhaust flow, which is coming up here. So this is all dry at this point. And then from the heat exchangers, our cooling water from the heat exchangers is going to come into here, which should be about 50 degrees, but then it's going to mix with the hot gases. Then that is going to then go through the hull and then overboard. That's the plan. I think actually we'll end up having like a loop down here of rubber exhaust, but today we're going to get it to this point here. So now we need to remove the temporary exhaust, which that will still be reused further down the line of the exhaust, but because it's a good silencer. But this will only be used when we're not running the cooling water going into the exhaust and blah blah blah. Right, so we need to remove that. I've been doing lots of other stuff off camera, lots and lots of wiring and little gizmos and stuff like that to control the charging. But we'll get into that later when we do a good test. So yeah, let's get the exhaust removed. Okay, so it does feel, I was a bit nervous about that. I made this the other day, so basically got two pieces of flat, put a space between it, clamped it all up, welded it up, and then cut a slit. So then when we tighten these down, hopefully it'll clamp it and keep it tight, but it's a real nice tight fit, so cool. Alright, so we need to potentially now shorten the exhaust, shorten this stub here. So we'll do some thinking now, how far back we need to cut it. Don't really want to take the manifold off just yet, but then because we want to keep it all nice and tight to the engine, don't we? So I know it's not the best work, but I'm using my really small MIG welder with stainless wire in it. So I've got like a dedicated welder on just for doing stainless. I really wanted a TIG, but I can't really warrant buying a TIG at the moment because I haven't really got the work for it. Cool, so yeah, we're going to shorten this down, and then this will then fit snugger to the engine, and then we'll figure out where our bends come off. So I've just been doing lots of head scratching. Maybe that's why I'm bald. Anyway, so got a loop, I'm going to call it. So we obviously need to come out with a pipe to move the gas. So originally I was going to come out with a pipe, then I was going to sleeve it with some more stainless steel. I've got like a bit of a little stock of stainless steel, but I've not got as much as I'd like. So I was going to then sleeve it with this one. So then on top of that one, I was going to put me fitting where the raw water comes in, and that goes in, then that goes around there, and then it'll come out. My concern with this is that there's not enough gap to allow for the flow of water. Because that would be the best solution, I think, to basically wrap it and then it comes out, and then because it all kind of equalises temperature then, but I don't trust that this isn't, I don't think it'll flow enough water. So when that goes into there, as in if we get a blockage, then there could be a problem. So that's the only two tube diameters that I've got. So option B, which we're going to go for, is found myself this 316 T-fitting, which handy dandy, that threads on. So we'll machine this down to accept the outlet from the heat exchanger. We're going to weld this into here, and then we're going to have some more 316 coming out, which will then rejoin our then rubber element to the exhaust. So what I've been debating over in my head is whether it matters whether the water comes in the bottom or the top. I personally think the bottom, because it actually works better with my plumbing, because the pipe will go to here rather than going up and over the top. And then even when the engine's stopped, you'll probably still potentially get drips. So I don't know whether the drips will make a big difference or a big deal, because the last thing you want to do is any water to come back up this loop here. So I think it's going to go on that way. Water is going to come from the bottom, and then obviously when the water is coming from the bottom, the engine's running, so we've got a movement of gas. That's where my head's at anyway. So that's going to go on there, and then we're going to have a longer tube is going to come out here. So I've basically checked dimensions on the marine exhaust rubber flex, and this is 45mm, you can get 45mm, so that's my plan. So before we weld this onto the exhaust, we're going to just true the end up, because I cut it on the bandsaw and it was all a bit wonky. So okay, so it's a bit flatter now. So I'll give all this a deburr and then we can weld that on. Not very good at stainless welding, turns out. I think it's this welder. Okay, so it's all tacked up. Seems okay actually, seems like a nice path, so give it all a good weld now. I think ideally you should heat it really before you weld it, so I've got a plan. So now officially run out of gas, these little pesky bottles. That one was full, did some testing the other week, but yeah, I've just completely emptied it on that. So it's not really worth me renting a big bottle, because my intention is one day is to be able to take this little welder to Surrender to see if we can weld through the inverter, or at least tack up on the boat, and then you can bring it here for some heavy welding. So yeah, I'm gonna have to go to the shop now and buy some more gas. Okay, so she's a nice snug fit. Shouldn't blow there, should she? Right, so it's all welded up. I'm not that impressed with my welding job, but with the small MIG, ideally it would have been good with the TIG, but as I say, I can't really warrant buying the TIG. Okay, so exhaust loops in. We've got the union to go on there. We still need to machine it yet, but what we need to do is sort of like put like a bracket from down here, from like the engine mounts up here. So, because obviously it could potentially twist, couldn't it, on the exhaust? So we don't really want it to sag, do we? So we need to like carry this part now, and then we can then maintain the angle. So what I'm going to do is I'm going to set like a bit of a fall, so any residual water whatever in the exhaust, it will go that way. So I've just been in my scrap pile and found this. It's like an old bracket, I think, that never actually got used for something. Stainless, probably A2, but so down here we've got a nice hard point. So if we come out with a bracket from there and then somehow carry the exhaust to stop it drooping. So I think we'll start by cutting that off. Okay, so we've got a nice bracket in now, so you can unbolt it, and then we can take the manifold, downpipe, whatever it's called, off. Yeah, so now we need to machine this to allow for the coolant exit to go on. So we're going to cut off this little swirly barb bit, and then we're going to machine this down to 25.5 mil. So we're going to use like a Worth 1 mil slitting disc. So apparently out of the factory, these aren't actually, that isn't parallel to that, so you can see it wobbling up and down. So if I had a 4-jaw chuck, I could censor it, but I have not. I've only got a 3-jaw, so we're gonna have to just keep machining away. It's gonna be ch-ch-ch-ch-ch. So I think what we need to do now is test it. So I won't bore you with all the plumbing and stuff, but I'm going to rejig the plumbing, get it outside, and then we'll give it a run, see if it moves water, and then see if it comes firing out the exhaust. And then we'll try and plumb in a bit of an exhaust system then. So I've actually got some, I was going to say helpers then, but you won't be helpers, will they? Helpers!
Oh, is it going to work? Is it going to work, Amelia? Yeah.
So we've now got a bucket of water, simulating our water goes into our raw water pump, through the heat exchanger, back out the heat exchanger, up into the exhaust, and then it's got to come out of this very, very temporary piece of pipe held on with duct tape. So we'll see if the duct tape lasts, shall we? And Amelia keeps poking her head round to try and distract me, so...
No, don't.
No.
Stay there. Amelia, I've told Amelia not to appear on camera in a school uniform because you can never be too safe with your kids and what school to go to and stuff like that. So that's why she's hiding.
What's beyond? That door's different.
Don't
Can you tell me about the door? Why you got a big door there?
Because we have a brand new workshop and my parents are going to be selling wood.
There we go. Should we go and have a little... It's not finished yet and it's still a work in progress because we're up the wall, but come into our workshop. See you later. Did you open that door?
Yes, sure.
What have you done in there? I've got a forklift, is that so?
No.
So all of the materials that we used to use when we were building vans, we're now selling big sheets of it. All like cut into like very usable sizes because we obviously know what sort of materials you use. So that's our new business venture. So we've moved all the workshop into there now.
It's been a long few weeks, hasn't it?
Yeah. And like we've put a big door on it to separate so we're not getting all the dust in here, aren't we?
Bye.
Oh good. Right, let's go and test this engine. Let me out. It works! There's no silencer, it's purely water. So the exhaust system works. It kind of had to word into it really because of like just physics and the water had to go up through. Obviously you can keep your hand on the down leg of the exhaust where the water's in it, but it's still a bit hot on the other end, so we're going to like wrap it with like some exhaust heat wrap. Right, so do you remember last time we were struggling to do a load test because we couldn't deplenish the batteries that quickly, could we? But I've now found a new technique. So if you look here, I've got some jump leads. You can't really see, but I've got welding wire. 2 legs of it. So basically got 2 pieces of welding wire in series, and then another 2 in series, so 4 in parallel as such. That's drawing a nice steady 50 amps. 47, I'm lying. So I can now deplete the batteries pretty quick, which is quite cool. If you put the ignition on, so we're now down to 21 volts. So we can now load it quite easily. So we'll do a quick load test, and then I'll tell you how I'm controlling the load on the engine. So try and describe what's going on, then I'll talk because obviously the engine noise and stuff. So. So they're like almost 100 amps. I mean, I have seen much higher numbers out of it, but we need to let the actual batteries we've got aren't that good, so they don't take that much charge. So this is our 50 amp load. Obviously it helps with the thermal. Can't really see at the moment on the floor, but when you put the thermal up against it, you can see our load. And it seems to be quite a good load. It's a very consistent load anyway. So since the last episode, I've done quite a bit off camera on the little generator. So I'll give you a quick show on what I've done. Bit of show and tell. So I've put a voltmeter. So the top one is saying 12.1. That's the start battery, and the low one saying 24 volts. That's obviously the house battery or the boat systems, but the two batteries that I've got as a simulation at the moment. I put a stop button up here, which we had a stop button, but we kept melting the stop button because, like, the amount of current the stop solenoid draws, it was melting these buttons. So I've actually put a relay in. So if you can hear the relay click. So I've also put this stop here. That stop there is going to be in the engine room, somewhere in close proximity to the generator. So if we go down there and like, oh my god, it's honking out oil or fuel or whatever, we can then stop it from downstairs. But we can also stop it manually, but electronically. So I've put a buzzer on it and a warning light. So that's to tell me that it's in the stop mode, because I actually melted the original stop solenoid. So I've had to improvise, and I put this solenoid on, which is off a starter motor. So you can sort of see it operating the linkage. So the reason I melted it is because I left it. Oh god, that's bright. Because I left it in the off position, and it really upset it. So to actually control the power, because we couldn't have it charging when it was idling, which was my main issue, because it was just stalling the engine, because it was drawing that much current and the engine didn't have enough inertia to keep the alternator spinning. So I had a cunning plan. So if you look here, we've got like a proximity, is that what you call it? So when the throttle linkage comes up, it's got a little magnet glued on there, so that it comes up, and then it'll activate this, which then fires a relay in here, which then activates the alternator to start charging. Which that was my initial design. So when it's at full throttle or 3/4 throttle, then it would engage. Still a bit unpredictable whether it was under cranking, because sometimes the throttle increases. So then I had another plan. So I put a volt sense relay, which you find in some camper vans, which is like an adjustable voltage relay. So when the voltage gets above a certain level, it'll then link to batteries, or it basically fires a relay. So I put it on the start battery. So when the start battery gets up to 14 volts, it'll then go right, thumbs up, and then if we've got a thumbs up off the other proximity switch here, it'll then say right, turn on the alternator. So obviously the engine's up to running speed because the start battery is up charged, or charging at 14 volts. Then it'll engage the alternator, and that's how we're basically controlling the load at the moment. And I've also got a potentiometer here, which is linked to the volt sense wire on the alternator, so I can then actually manipulate if I want to charge harder or slower. Well, I can charge harder, but I can't really come down lower. I have actually got like a voltage booster, but I don't think I really need that. So yeah, it's actually all working really well. So I'll run it now and then try and show you. You'll see like a little light come on the back of the proximity switch. So now we'll go to a start. So obviously it's on idle now. That sun's really bad, sorry. You see it actually engage, and you can hear the note change. So if I go back to idle, so this switch here is turning the alternator on and off. And then, I don't know if you better see the bolts. So I think that was quite a success, wasn't it, really? I think the exhaust worked alright. Time will tell, I think. Everything seemed to run cool. The engine actually run cooler like that. I think it could move more water faster, especially past the heat exchanger. So she's not far off ready to go in the boat. I need to do put some like nice cables in off the alternator, some new cables on the start system. I think I'm going to come to around here with some big fuses so we can then just hook it straight into the boat. I need to make sure she'll actually go into the boat as a whole. So I'm planning on making like a crane so that we can lift it off the boat through the door, but I want to make sure it'll fit through the door and then we can get it downstairs. If not, we'll have to take it apart and take it down in pieces then rebuild it, but it's better to go in one, isn't it? So yeah, that's about it really. I want to say a massive thank you to all of our viewers, and especially the patrons who really help us out. If it wasn't for them, if it wasn't for you guys, we wouldn't be able to do stuff like this. So to be able to sort of revive Surinder. So yeah, cheers guys, thank you so much. Obviously all this is going to be removed and cleaned up, but didn't even put any bolts in my little clamp. Apologise about the welding. Thank you.